Good morning, folks. This is Mr. Walker here, coming to you with our next round of notes for Area 2D figures. So let's jump right in there. What is area? Area is the amount of space or region occupied by a two-dimensional figure. Now, before we jump into the actual formulas, let's talk about a couple of, just some helpful tips for calculating or finding the area. So, first thing we want to talk about, we're going to be using the letters B and H for a lot of different things. B is what we call the base, and H is going to be the height. These two things are going to be perpendicular to each other. So whenever you're looking for the height for your height's going to be lined up with the bottom of your shape near a right angle. So if you look for a right angle, that's usually going to indicate where your height is on that line. After this, we also know sometimes we got a lot of information that we talk about for a shape. So you only want to focus on the measures that are relevant. Not everything we look at on the shape is going to help us to it. So take your time. You're only looking for a couple of things. Next thing we got. In obtuse triangles, look outside the triangle for relevant measures. So for some of our shapes, we're going to have to look outside of it because they get a little bit crazy. They're not all nice and easy for us to go through and calculate on the inside of it. Some of the time, whenever we have to go through and find the height for a shape, especially, we kind of come outside the shape and just try to use that little vertical length so that we can go through and mark that as the height. Final little tip before we jump into some formulas, folks. When relevant info is missing, sometimes you're going to figure out a length before using the formula. So let's jump into our formulas. First one we got is our friend the parallelogram. Just as a reminder, for most parallelograms, you are going to be able to use this same formula. The area for a parallelogram is base times height. Base B, that's at the bottom of your shape. Height H, that is that dotted line that you see in there where that right angle is meeting at the bottom. So that's your height. Whenever you're seeing slanted shapes, especially like this, or this, these all involve H as our height, and they're going to indicate that using a right angle and, a little bit of, approximation with these dotted lines, just to bring your eyes straight to that. So let's look at a quick example. Here's an example of a parallelogram here. On the bottom, we have 11 inches, and then next to this vertical dotted line, this is 6.5 inches. Now, when you look at that dotted line, it's attached to that right angle that you see there. So that perpendicular length lets you know that this is the height of your shape. Remember, when we look at height, we're always looking at how tall we are when we're standing straight up and down vertically. So whenever you're looking for the height, it's usually some sort of up and down length. So what we do here, we just take 11 times 6.5, and that gives us 71.5 inches squared. A couple of things to go through and recognize here. Whenever you see inches squared or whatever unit they give you squared, that's just telling you that you did some multiplication so that you don't have to worry about where did that come from. All right, next one we got here, we're talking about a triangle. So for a triangle with base B and that height with that dotted line H, the area of a triangle is 1/2 the base times the height. So you take a look at your triangle. Your base is usually going to be easy for you to find. It's at the bottom of the shape. The height is going to be attached to some sort of perpendicular length. So you're going to be looking for some dotted line in, out, around the shape to get you to where you need to know. So for this is where not paying attention to all of the lengths in mind are going to really come into play. So let's first look at our base. On our formula, B was on the bottom of our shape. So which one of these lengths is the bottom of our shape? Well, first, let's look at what our shape is. I'm going to highlight this shape real quick in blue. So our shape comes from this top corner, coming on down to right here, coming across to here, and then back up to here. So these are the parts of the actual shape. 4.5, 9, and 7.2 down here. These two things to the side, the 4.5, see how it's on this dotted line going up and down? This is going to be our H. The 7.2 was used to go through and help us figure out what the height was. If you see this right here, this is a right triangle. So sometimes they do the Pythagorean theorem to go through and find out missing parts. If that's something that you might end up having to deal with, remember, it's just another thing in our toolbox so that we can find it. Now, what's our base? Our base is just the bottom of our shape. So this right here, that's our base. So when we do our math, the area is 1/2 7.2, the base, times 4.5, the height. When we multiply those and take half, we end up with 6.2 meters squared. When you see that little square on that unit, that's just letting you again know that you did some multiplication. All right, next one we got our friend in the trapezoid. The trapezoid is a little bit different from our previous two. It does have us multiplying by the height, but this shape has two bases, a top base and a bottom base. So we add those two bases, multiply it times the height, and then take half of that. So sometimes your trapezoids will look just like this. Other times they may look a little bit different. They might go through and hit this on a different side. Now, first thing we got to know, what is our base 1 and base 2? We look at all four of our sides here, and we can determine which ones are our parallel set of sides. So, can you say 8 and 7 are parallel? I don't think we can. See how 8 right here is on a slant? If we brought this up and kept going on and on and on and on, it'll be somewhere down over here. And if we continue this side on and on and on and on, it would end up meeting with that side over here. So these two are not parallel, 8 and 7. But when I look at 9 and 12, I can tell that these guys here are parallel because they're just going in the same direction, straight up and down. So we got both of our bases. Let's go through and get some, better penmanship here. So over here, 9, that is our base 1. And then over here, that's 12, that is our base 2. Now, what is our height? Our height is a vertical length that you're seeing here, connecting the top to the bottom side, and is perpendicular. Now, we don't actually have a whole lot here that we can extrapolate, but we can tell one thing. Is this line going straight up and down? This is more slanted. So this wouldn't be our height. But this one is straight up and down, connecting from here to here. So we're going to call 7 our height. Let's actually draw that a little to the right. All right, 7 is our height. So our area is 1/2 7, our height, times both of our bases added together, 9 plus 12. When we have 9 plus 12 times 7 divided by 2, that gets us 73.5. So you have to pay attention to your shape, deal with it as you need to, and just take your time. Next one we got here, we got our friend the circle. Our circle is pi r squared. Now, a couple things to remember. What is pi? Pi is an irrational number, but sometimes with pi, we always use a little placeholder. Do you remember what that placeholder is? It is 3.14. This is just an approximation, so we don't have to deal with the decimal, how it is, all the time. So, this shape right here, is it the same kind of shape that we have from our example? Yes, it is a circle, but does it have everything we need? In this case, they gave us a diameter because it's going from one end of the circle through the center to the other end. So if this is the diameter, I need to find half of this, the radius. Our radius is always half the diameter. So we take 9, we divide it by 2. This is going to give us a 4.2 for my radius. So our area is 3.14 times 4.5 squared. And when we go through and calculate that, that gets us 63.6 centimeters squared. All right, halfway there. Let's get these next two down. Now, unlike our previous two, these ones are not going to be using just base times height. We're actually going to be taking part of our diagonal lines in the shape, and we're going to be doing something with them. So, when they give you this right here, this D1 is really only referring to this half of the line. Let's go through and highlight it. When we talk about D2, D2 is talking about this half of this diagonal line going straight up and down. So do we need the whole thing? We only need half of it. So the area of our rhombus is 1/2 diagonal 1 times diagonal 2. So here's our rhombus here. We got our two diagonals. Remember what the diagonals do in a rhombus. They bisect each other. So we take our two diagonals and the halves that they give us, 3 and 9, and we take 1/2, 3 times 9. 3 times 9 and divided that by 2 gives us 3, no, not 3, 13.5 meters squared. All right, that was for our rhombus. Let's talk about our friend the kite. Same type of notation here. They give us D1 and D2, and this is also going to have a similar formula. D1 times D2, and we're going to take half of that. So here's our two lengths here, 7 and 11. What we go through and do, we take 1/2 of 7 times 11. And then 1/2 7 times 11 gives us 38.5 inches squared. All right, that's all of our formulas here, folks. Now, without further ado, let's get some practice in, people. Go ahead and pause this video and go ahead and try to see if you can go through and answer these guys. Hello, folks. Hopefully, you're able to go through and pause the video and try some of these out. But if you didn't, it's understandable. Sometimes you want us to go through our work together. If that gives you comfort, I understand. Let's go through and talk about this. First, we want to look at the shape. We want to identify the shape, and then we want to do what we need to do with that shape. So, first thing they give us, I see I got 4 sides, so it's a quadrilateral. If I look at 2 of the sides here, it looks like this top side here and this bottom side are both going in the same direction. So because of that, I'm led to think that this and this are the bases of a trapezoid. So we got base 1, we got base 2. Now, since both of these sides are slanted, we're looking for this dotted line here for our height. So this dotted line that represents our height is the 7.4. Now that we have this, let's do some math. 1/2 7.4 times 10 plus 14. When we put that all in the calculator, that gets us 88.8 feet squared. So try to keep the decimal on there and don't go through and round this all the way out to the nearest whole. Because if it's approximate like this, if we're going to get a decimal, I'd rather the decimal, to be honest. Okay, next one here. First off, what type of shape is this? Now, if this were a rhombus, all 4 of the sides would be the same size. So because of that, I know that this is actually a kite. This is 8, this is 5, this is 5. So because this is a kite, we got our 2 diagonals. We got D1. Ooh, sorry about that, folks. So up top, we got D1. And then I got over here, this is D2. So we're going to take 1/2 D1 times D2. So 3 times 12.7 divided by 2 is going to give us around 19.1 inches squared. All right, next one that we got here. I see that they gave me only one length, 9.5. Now, why would they only give us one length? Well, do we look like we have 4 sides here? Yeah, we do. Does it look like we have two pairs of parallel sides? Yes, we do. Now, if we have two pairs of parallel sides and we have four sides, it's a parallelogram. Usually, if they give you just one length like this is an indicator that this might be a squared or a rhombus. I would say that this is more of a square because these sides do all look the same, and these angles to the side look like they are around 90 degrees. So it's a safe assumption for us to think, this might be a square. So what we got here, we got our base that is going to be 9.5. Our height, because this is a square, is also 9.5. 9.5 times 9.5 gets us 90.3 inches squared. Last one we got over here on this row, we got a circle. So for this circle, we're going to have to go through and do this nice and easy. They gave me the radius already. We got 3.4 times 13 squared, which gives us around 530.7 centimeters squared. Nice and easy, people. All right, last two that we got here. We got us a triangle on the left, and it looks like over here to the right that we got us a rhombus. If it's not a rhombus, it could be a kite, but remember those formulas are similar. All right, first thing we're going to want to do we have a height here? It does not look like we have a height here. Because of that, we need to go through and find it by using our old friend, the Pythagorean theorem. So, because of that, that lets me know this side right here, my height, is 7. So 7, this is the height of my triangle. And this side here, 24, at the bottom, that is our base. The triangle's formula is 1 half base times height, which is 1 half of 24 times 7, which is going to give you 84 feet squared. All right, final one that we got, and then we are going to get to what we need to get to. We got us a rhombus or a kite. It could be either one. Luckily for us, those formulas are the same. So we take 1 half our two diagonals, 1.1 and 3.4, and that will give us around 1.9 meters squared. Folks, it looks like we are out of here. Make sure you tune in. Tune in next time for our next round of notes. Appreciate y'all for watching. See ya.